This lesson will teach you to work with trigonometric functions, also known as trig functions. The main trig functions are sine, cosine, and tangent. They are written in terms of theta. This is the symbol for theta. Sometimes you may see an x or an angle degree. These functions are referred to as trig ratios. Trig meaning trigonometric, ratios meaning a fraction. Ratio is just a fraction of one number over another number, specifically these three quantities. Because we're dealing with a fraction, you'll have one number on top and one number on bottom. So depending on whether you're dealing with sine, cosine, or tangent, you'll use two of the three. Opposite. Opposite means that it's across from the theta. Adjacent means it's next to the theta. And hypotenuse is always opposite the 90-degree angle. Let's work with these three terms. Identify the sides and angles. Theta is your reference angle, meaning this is the one that we're looking at. Triangles have three angles, but you're going to be looking at the one specifically that has the theta marked. So thinking about this theta, the side that is opposite theta. So you start with theta and go all the way opposite or across the shape. Adjacent is the one that's the side that's closest here to the theta, and hypotenuse is always the one that's opposite the 90 degrees. Let's try it for the other triangle. This time, notice that theta is in a different location. Theta is located here. So you're going for sides that are opposite of theta, next to theta, and then hypotenuse will always be the leg that is across from the 90 degrees. So opposite. Start with theta and go all the way across the shape. Opposite is here. Adjacent. Start with theta, it's the one next to it. And hypotenuse is that side that's always across from the 90 degrees. All right. The next slide is covered because it'll be uncovered as you go. So the first trig ratio, sine, is abbreviated SIN. It's not sin, you haven't done anything wrong. It is sine theta. This theta is important as it's the angle that we're dealing with. As you get into some of the problems, this angle or measurement will be replaced by a particular measurement, 45 degrees, 30 degrees, 100 degrees. Sine is the ratio of the opposite side length over the hypotenuse. So being able to determine opposite over hypotenuse is important for these. Looking at your reference angle theta, opposite, hypotenuse, so whatever number the opposite is will go here. Whatever number the hypotenuse is will go here. Make sure you have that on your paper under sine. Now let's look at some practice problems. All of the slides dealing with practice problems are split into two portions. The first one, all you're doing is setting up the fraction. You're not solving for anything. The second, you're setting up your ratio or your fraction, and then you're finding the value of the variable. You will need a calculator for finding the value of the variable, and I do not recommend the calculator that is on your iPhone. Sine. The sine of theta is always going to be sine theta. The value that you label as the opposite is going to go on top of the fraction. The value that's the hypotenuse is going to go on the bottom of the fraction. So let's see. I would label, if this is my theta, opposite is going to be the 6, hypotenuse is going to be the 10. So the ratio you're writing, sine of theta, equals 3 over 5. You definitely need the theta. It has to be included. And the second one, opposite, hypotenuse. So if you think about plugging those numbers into this particular fraction, sine of theta equals 2 over 7. Now that we've worked with setting up the fraction, let's deal with actually solving them. So notice the problem is nearly identical to the one above. The only difference is that the 6 has been replaced by a variable, and we're going to try to find out the value of the variable. Please notice as well that the theta here is a degree symbol. We have the x is the opposite. We have the 10 is the hypotenuse. So the fraction that I'm going to set up is the sine. I told you that theta was important. Here our theta is going to be 60 because we were given a number. The value that is opposite goes on top of the fraction. The value that is the hypotenuse goes on the bottom of the fraction. Here we have an equation. We need to get x by itself. Think back to Algebra 1. To undo division, we use multiplication. In your calculator, you're going to type 10 times the sign. When you hit that sign button in your scientific calculators, it's automatically going to open up that parenthesis. I do recommend that you get in the habit of closing it, as it'll be needed later. I'm going to use the graphing calculator desmos.com, which is a free downloadable app, to show you how to type this in. First thing, if you are on one of the OGT calculators, a scientific kind of red basic calculator, you won't need to worry about this next step. If you have any sort of a graphing calculator or you're using this particular app, please pay attention. If you're on a graphing calculator, I believe the setting is in your mode, but you need to make sure that we're working with degrees. Radians and degrees are two different units of measure. Think about inches versus centimeters. If you're working in inches, but your calculator is set to centimeters, which may not make a whole lot of sense, but we need to make sure we're all in the same units. Because the problem deals with a 60-degree angle, we need to make sure that the calculator knows that we're working with degrees. All right, so the problem that we just worked on was the sine of 60 equals x over 10. We multiplied 10 by both sides, so I had said to type in 10 times. For those of you on any sort of a graphing or a scientific calculator, your sine, cosine, and tangent functions are clearly labeled. If you're on this Desmos app, I do have to get into this little menu. Notice the parentheses. The directions to the problem on your notes say round to the nearest hundredth. I see that this is a 8.660. That's going to say 8.66. 8.66. X equals. So this particular side length is 8.6. All right, the second one. Let's see. Here is that reference angle. So the 2 is opposite the reference angle. The x is the hypotenuse. So here's the equation I'm setting up this time. Sine of 55 equals 2 over x. The difference between these two problems is in the preceding one, the 10 was in the denominator, so we multiplied both sides by 10, and x was left on its own. In this particular problem, I do realize that the x is already in the denominator, but let's go ahead and solve it the same way. If I can get the x out of the denominator, I undo division by multiplication. This problem isn't any more simple yet, because I now have an extra step, and that's kind of just the nature of the problems when the x is in the denominator. I know that this looks messy, but believe it or not, it's just a number. It's a decimal that's being held together with that variable by multiplication. To undo multiplication, I'm going to divide. So, let me get a little bit more space here. X equals 2, in this case, divided by the sine of 55. Your calculator, when you hit sine, is going to automatically generate at least one pair or one parenthesis. Just make sure you're closing it. I'm going to go back to that Desmos graphing calculator, and I am typing in, let's see, 2 divided by, oops, the sine of 55. 2.44. X is equal to 2.44. Please pause your video and try the next one. All right, so I got x equals 5.42 by placing the opposite over the hypotenuse and solving. Here I was able to just multiply 9 by both sides and type it in my calculator. The next trig ratio, you may have to look back up on your paper to write this down, is cosine, abbreviated COS, of theta. This is the adjacent over the hypotenuse. Adjacent meaning the one that's directly next to. Hypotenuse is still in the same location. When we go to set up the following practice problems, again I would label. 2 here is the adjacent, 12 is the hypotenuse, so we're going to use cosine theta equals 1 over 6, and I'm only saying 1 over 6 because that's what the fraction 2 over 12 reduces to. Not a big deal if you don't reduce. next to is adjacent, hypotenuse is across from the 90 degrees. So in this particular case, cosine of 5 over 11. Finding the value of the variable in each triangle. Again, I'm going to start by labeling. Whoops, got to label it correctly. 11 is the hypotenuse because it is directly across from the 90 degrees. The x is the one that's adjacent. Hypotenuse, adjacent. So I'm going to set up these two problems. The cosine of 50 equals the adjacent value over the hypotenuse. The cosine of 57 equals the adjacent value over the hypotenuse. The good thing is that solving them is the exact same as it was for sine. Times 11 times 11. Type this into your calculator. I ended up with x equals 7.07. When I go to do this one, I'm going to multiply both sides by x. Problem with the x being in the denominator is the problem's not done yet. It's still being held with the cosine of 57. So by dividing by this whole thing, and I know it looks kind of messy, but cosine of 57 is just a number, it's a decimal. X equals 2 divided by, grab your calculator and type it in. I got x to be 3.67. Go ahead, pause your video, and try the third one. Go ahead and check your work and see how you did. I have my adjacent hypotenuse labeled, so the cosine of 35 equals the adjacent value over the hypotenuse. I was able to clear the denominator by multiplying both sides and then typing it in my calculator, making sure to round to the nearest hundredth. All right, and then here's the whole screen. So look back up again to your trig ratio section. Tangent is the last one, abbreviated TAN of theta, and this is the opposite over the adjacent. If you notice, this is the only one of the three that doesn't involve hypotenuse. So tangent, here's opposite, it's all the way across. Here's adjacent, opposite, and there's adjacent. So we're going to use tangent of theta equals the opposite value over the adjacent value. The opposite value, if you think about the tangent of theta, is 2 over 4, which all I did was reduce. Not a big deal here if you didn't. Your calculator will ultimately take care of it. Tangent of theta equals 5, the opposite value, over 7, which is the adjacent value. Find the value of the variable in each triangle. I'm going to start by labeling. Opposite, adjacent, opposite, adjacent. So when I set up my tangent ratio, the tangent of 37 equals the opposite value over the adjacent value. The tangent of 62 equals the opposite value over the adjacent value. Solving these is exactly the same as it was for sine and cosine. I'm going to take the value in the denominator and multiply it, because that is how I undo division. 7 times the tangent of 37 equals x. My calculator can take care of that problem. See, I got 5.27. Here, I'm going to do the same thing. I'm going to multiply by the denominator. But because that x was in the denominator, this one has one more step. Because the x is being times multiplied by the tangent of 62, I'm going to divide both sides. X equals 2 divided by the tangent of 62, and my calculator can handle that one as well. Pause your video and try the third one. All right, go ahead and check your answers. Notice I have my opposite and my adjacent labeled, so the tangent of 52 is the value that is opposite over the value that is adjacent. I multiplied both sides by the value of x, and in this case then had to divide. When I typed it on my calculator, I got 3.125 blah 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 blah. Because we're rounding to the nearest hundredth, and that's a 5, it made it round up. The last slide that I'm going to go over with you, just as ways to remember, it is referred to as SOHCAHTOA, telling you that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Please complete the following problems on your own. Thank you.